Let's look at sine law and cosine law review. First thing, the sine, cosine, and tangent ratios are used for right triangles only. So we won't be using just those ratios. If we have what we call oblique triangles, which are triangles that do not have a right angle, then we can use the sine or cosine law. Starting off with sine law, there are two ways the sine law equation can look. It can look like this. So side A divided by sine of angle A equals side B divided by sine of angle B equals side C divided by sine of angle C. Or the whole thing can be flipped upside down. Both of these equations will work. Now it's very important to understand that when we say side A, now we use lowercase letters for the side lengths, we have to divide that by sine of its opposite angle. So A is opposite of angle A, B is opposite of angle B, and so on. So we have to make sure that we exactly match those up. In general, sine law can be used when you know the measure of one angle and its opposite side. Basically, you have to have the numbers for at least one of those ratios in order for sine law to work. So using sine law, we're going to find the measure of side B. The question says using sine law, so obviously we're using sine law, but why will sine law work in this case? Well, we have to have the measure of one angle and its opposite side. If you take a look at this triangle, we actually don't have that. We have this angle, but we don't know what side B is. We have this side, but we don't know angle C. We have this angle, but we don't know side A. But using our knowledge of triangles, we can actually first figure out what angle C is. So we figure that out by, and notice how I'm actually showing my work here, 180 degrees minus 47 degrees minus 58 degrees tells us the angle C is 75 degrees. So now that I know that this angle is 75 degrees, now I have that opposite side and angle pairing that will allow me to use sine law. Now I can set up the sine law equation, and you may ask yourself, well, which one of these do we use? Either one will work. What I like to do is I like to put my unknown value on top. So I'll put side B on top. So that will have to be divided by its opposite angle is 58 degrees, so divided by sine 58 degrees equals, at this point, this is when I use the pairing that I know, so 33 yards divided by sine 75 degrees. At this point, I have to solve for what side B is, and the reason why I like to put the unknown value on top is because it's being divided by sine 58 degrees. Well, we know to isolate side B, I have to multiply the other side by sine 58 degrees. So 33 divided by sine 75 degrees will be multiplied by sine 58 degrees. Now B is isolated, so all I have to do is calculate this, and I'll get a measurement of 28.97, so that will round up to 29.0 yards. So just remember, just like when we did our other trig work, I'm not using any decimals here. I'm not rounding anything until the very end. Very, very important that you do that as well. The next example, I've already written out the solution, so you can take a look at it. But this time we want to figure out what angle B is. So this time I've put, again, my unknown value is angle B, so sine B is on top, divided by its opposite side, 25, equals, so the pairing that I have is sine 75 degrees over 33. Just like before, I want to isolate sine B, so I multiply the other side by 25, but remember that that gives me sine B, not what B actually is, the angle. So in order to get rid of that sine there, we do the inverse. So sine inverse of everything that was on the other side of the equation, that's what the sine inverse applies to. So I will get 47 degrees approximately. So both of those examples were sine law questions because we had one angle measurement opposite of one side measurement. That lets us use sine law. So in what cases do we use cosine law? So cosine law is used when you have now we use the abbreviation SAS for side, angle, side. That means that you have an angle sandwiched in between of two side lengths, and you have the measurements for all three. Or SSS for side, side, side. So with all three sides of the triangle, you can actually use cosine law. So this is the cosine law equation, c squared equals a squared plus b squared minus 2ab cosine c. It doesn't have to be necessarily c that you are finding. C is just whatever side you are finding. And we don't have to algebraically rearrange the equation. So for example, if I'm finding side A, the other two sides are what I'm adding the squares of. So it would be b squared plus c squared minus 2. Now if you take a look, the two sides that we multiply here are the same as the two squares that we added. So in this case here, it would be times 2bc, and then cosine of whatever the side is that we're finding, that angle A. Okay, so we're not algebraically rearranging the equation. We just kind of substitute in the side that we want and the angle that we want. To find a missing angle using cosine law, it's the exact same equation algebraically rearranged so that cosine C is isolated. So you can remember this formula, or you can actually rearrange the other one if you like. So the way to remember this one, cosine C, so we're finding angle C, if you take a look at the three squares in the numerator, it's the same side, C, that we are subtracting. So the same side as the angle, that's the one that is subtracting. Divided by 2ab, so we multiply the two that are adding in the denominator. So I'll show you an example of using cosine law to find a missing side here. So we want to find side B. So first thing, it's not labeled on the triangle. So I know that side B is opposite of angle B, so it'll be right here. This situation that we have right here, we have a side length, we have an angle, and we have a side length. So side, angle, side, the angle is right in between the two sides. This is a cosine law problem. You can also see that we can't use sine law because we don't have one of those opposite angle and side patterns. So I'm going to write out b squared equals. Now what I do at this point is I take the two sides that I have and I add up the squares of them. So 27 squared plus 25 squared minus 2 times the first side times the second side times cosine of whatever angle B was, which is 65 degrees. Just like before, we want our answers to be as exact as possible, so I'm not going to type this all in and get a decimal value. We're just going to think ahead here, and what would you actually do with that number? Well, this tells us what b squared is. So we know that we have to square root b squared to get just b. Well, if I square root one side of the equation, I'm going to have to square root the other side as well. So I'm going to square root this whole thing. Now, on my calculator, I can type out this whole thing. You can probably do the same with yours as well. But if you can't, just remember that you should not round any of this. You'll have to write down all the decimal places it gives you. Otherwise, your answer will be slightly off. That's finding a side length using cosine law. So just very quickly again, I've already filled in here to find angle C to the nearest degree. So this is a side, side, side situation. I have all three sides of the triangle. So I want to figure out angle C. For finding an angle, you see that I have the squares of all three sides. The question is always going to be, which one do you subtract? So what I said before was, whatever is opposite of the angle you're finding, that's the side that you subtract. So I'm subtracting 15 squared. 16 squared plus 14 squared minus 15 squared. In the denominator, I have 2 times, and then the two sides that we're adding, 16 times 14. What you'll notice here is, for solving this, again, I'm keeping things exact. So all I've done here is I've simplified the numerator is 227, and the denominator is 448. So something like this before, this is what we would solve back when we did right angle trigonometry. So if cosine C equals 227 over 448, do the cosine inverse, and then we are good to go. So again, no decimals at all. Everything is exact right up until the very end.